Oh, my fault. I thought I had projected this up there. All right, so here we go. Right here, the area of the region bounded by two graphs. All right, y'all see f of x right here, and that's g of x, and then there's a region in between it. All right, that's the area we're looking for. It's bounded by two graphs. So the function f, the function g, here's where it's bounded. So this is the top, this is the bottom. All right, and we want the area in between. All right, so when it's like this, when we have two functions and we got to find the area in between, we're going to integrate from a to b of f of x minus g of x dx. All right. So we figure out what the top function is, and then we're gonna integrate that. We're gonna subtract the bottom, and then integrate. For this one, notice g of x. All right, it's not a factor right here. All this is f of x. You see that? So for this one, from a to b, we integrate f of x dx. And then for this one, you see there's no area underneath the f of x, just g of x. So we integrate that from a to b of g of x dx, like that. All right. Now, let me show you how to do these. The main thing is just if you can identify the top and the bottom in your calculator, you can do these with no problem. All right. So that's a terrible sketch, but yeah, my fault. Hey, yo. Hey, y'all put your phones away, man. Phone, put it away. Put your phone away. Put your phone away. Put your phone away. Especially put it off your desk. Off your desk. Hey, yo, Mr. Dockery, come on, man. Put it up. All right. Right here, find the area of the region bounded by the graph y equals x squared plus 1 and y equals x for the interval 0 to 2. Sketch the shaded region. So look, in your calculator, you're going to graph those two equations. So you have y equals, what was the first one? X minus, what was it? X squared plus 1, thank you. And then the other one was y equals x. All right, and then we graph it. So this is x squared plus 1. And here comes x, y equals x. All right, so notice how it told us we're bounded between 0 and 2. So we want this region right here. So when you sketch it, you're sketching this right here, this region right here from 0 to 2, right? Now, which one's the top and which one's the bottom? The blue is the top, right? So this is x squared, what was it? X squared plus 1, and then this is y equals x. That's the top, that's the bottom. So you sketch that, of course, like I tried to do right here. Now, after you sketch it, we set up our integration. So we're going to integrate from 0 to 2, and we said the top was the parabola, right? So we're going to do x squared minus 1 minus the bottom, which is x. All right, dx. That's the top. The parabola is the top of this area. You see what I'm saying? The y equals x is the bottom of this area. Yes, ma'am. Oh, because we're using both of these, you're going to use both of them. This is a matter of which one. The top one goes first. The second one is the subtraction. All right. So it's top minus the bottom. Oh, plus 1. Thank you. Plus. I'm sorry. X squared plus 1. All right. So now, listen, like, and some of y'all gonna see, man, like, make sure you show your work on this. All right. And showing your work just consists of this: integrated. So we have x cubed, over 3 plus 1x minus x squared over 2. All right. From 0 to 2. So that's the integration right there. And then you just got to show f of 2 minus f of 0. And so you literally, guys, plug this into your calculator. Your calculator will do the work for you. So, and I'm just going to show you. When we took the integral, we had, what was it, x cubed divided by 3 plus x like that. All right, then we hit graph right there. Now, we just need two values from this table. If you look at your table, we need 0, which is 0, and 2, which is 2.6, right? 2.7. So this is 2.7 minus 0 is 2.7. Oops, 2.7 units. You see what I'm saying? So again, identify which one's the top and the bottom. Integrate it, or subtract them, integrate it, and then just plug in your values. They're already in your table. And then this will be you showing work right here. All right, you just got to integrate it, show that you can integrate it, right? And then this right here tells me that you're evaluating this for f of 2 and f of 0. Yes, I just plug this in to the calculator. And then the calculator is going to calculate all this for me. All right. Here, let's do another one. And I already put the sketch here, but anyway, let's graph it. X squared minus 4x plus 4. And what was y? Y equals 4, right? So look, listen, we want the area in between, right? So we have this portion right here, and we have this portion right here, the parabola. Where's the in-between portion? Be this right here. All right, so what's the top? This is the top right here, that red line, and the bottom is the blue line. All right, because we want the area in between. So I got that sketch over here. So now we know what the top is. The top is, I'm sorry, from 0 to 4. The top is what again? The 4, and we're going to subtract the bottom. Which that simplifies to 0, 4 minus x squared plus 4x minus 4, right? Which simplifies actually a step further to negative x squared plus 4x dx, right? Because 4 right here, 4 minus 4 is 0. Y'all understand why I did 4 first? It's the top. So now we integrate that. Right? So there's our equation right there. And again, you can just take your equation, put that into your calculator, negative, what was it, x cubed divided by 3. What's the rest? So 2x squared. Oops. Disregard the red line. I forgot to take that out. We don't need that anymore. But anyway, I just need that first table. So I go here and look at it. We said from 0 to 4. So 4 is 10.7, and this is 0. So f of 4 is 10.7 minus f of 0, which is 0, equals 10.7 units. So we go right there. And again, your calculator, man, does it all if you just trusted it. All right, we have no intervals present, so we got to come up with our intervals. So before we even start, before I graph it, what I'm going to do is set these two equal to each other. These two functions, set them equal to each other. So now I'm going to take, I don't want my leading, y'all see the degree is 2. I don't want that leading coefficient to be negative, so I'm going to move everything this way. So I'm going to add over x squared and subtract 3. So now, since it's equal to 0, we can factor this trinomial. So we get x plus 3 and x minus 1. And when we set those equal to 0, we get x is negative 3 and x equals positive 1. So these are our values we're going to use right here. These are our intervals now. So negative 3, negative 3, sorry. Negative 3 less than equal to x less than equal to 1. All right. So then we graph it. This one was 3 minus x squared, right? And this one was 2x. So we graph it. So now, where's the top? The red or the blue? The blue's the top, the red's the bottom. All right. And there's our region right there. All right. So that's the shaded region you look at. So now we integrate from, what we say, -3 to 1. And the top was the parabola. So 3 minus x squared minus 2x dx. The top was the parabola. So that's the parabola minus the straight line right there, 2x. So we get 3x minus x cubed over 3 minus 2x squared over 2 from -3 to 1. Or 3x minus x cubed over 3 minus x squared, like that. So we punch that back in our calculator. I forgot. Can somebody tell me what it was? No. The integrated. 3x minus x cubed over 3 minus x squared. And so now, we go to our table again. And we want -3, which is 9, and 1, which is 1.67 or 1.7. So we have 1 point, oh, I forgot already. 1 was 1.7. So I'll go 1.7 minus a -9, right? What's it going to be, 10.7 units?